Okay, good morning, everyone. Thanks for joining. Let's kick off the show. Ricardo, I will pass over to you. Ricardo, you can do the introductions of everyone, and best luck with the session. Good luck to you.
Okay, thank you, Tom. So this is going to be a fun session. We're going to do a live deployment, and for this, we have a special guest here. We have David from Equinix, so it's going to be a joint session between Oracle and Equinix. So hope you like it. So the first thing, Ejaz, if you want to start presenting yourself, telling us a bit more about it.
Hey, thanks, Ricardo. Good morning, all. So my name is Ejaz Akram. I'm part of the Multicloud Solutions Specialist team here at Oracle. Just glad to be here. Going to share some of the slides around what we're doing in Oracle with Multicloud and take you through the rest of the deck, basically. Thanks. David?
Thanks, Ejaz. So David Tairych, I'm the special guest from Equinix. So I'm a pre-sales architect as part of our digital services portfolio. I did see in the poll, a lot of folks aren't so familiar with, I guess, Equinix's offerings in this space. So it's going to be quite interesting to see, how we can stitch together Oracle's value proposition with some of the things that we can do as well. So back to you, Ricardo.
Yeah, so well, I'm Ricardo, and I worked also in the same team as Ejaz. So here at Oracle, we have a team specifically working on multi-cloud solutions. So this is where we are. So we love multi-cloud solutions, and we love simplifying this. So, okay, so now let's get to the interesting things. So David, you can go and start with showing us what we're going to be doing here. I believe you're on mute, David.
You think after how many years of Zoom we'd be used to this, but not quite there yet. But as Ricardo mentioned, today's all about a live deployment, right? We want to show how we can use approaches like infrastructure as code to automate the hybrid cloud journey for Oracle customers in connecting other cloud environments as well. And this is really where Equinix sits. And we're going to get more into, I guess, the services that underpin this overall solution. But the theme is to move away from ClickOps. And again, I saw on the poll that not so many folks are using infrastructure as code as their primary deployment method. But it's still nice to see how we can use some of these components to bring together end-to-end environments. So I'm actually going to kick this environment off, and it's going to sit here in the background and run whilst we go through the rest of the presentation. And we'll come back and describe just exactly what we've done here and actually view the end-to-end architecture once it goes live. So with that, we're going to revert back to the slides. We're going to give you some context, a bit more background around this actual deployment, and then we'll come back to see what we've actually done in the background. And we're going to get into, I guess, some of the Equinix services that underpin the deployment that we're running. And this might be a refresher for some, and it might be new for a lot of folks, but there's really two main components that we're using in this live deployment to bring together the multi-cloud environment. The first is a platform we call Equinix Fabric. It's our global software-defined network, which is really there to enable on-demand connectivity between participants of Equinix's ecosystem. And our biggest ecosystem participants are the hyperscale clouds. So the likes of Oracle and other large clouds like AWS, which we're going to be demoing today, deploy edge infrastructure in close proximity to our facilities, and that's then reachable via the Fabric. So we act as that intermediary between the clouds, that neutral place where they all seem to land. And Fabric provides, I guess, the base networking between those cloud environments. Now, as I mentioned at the start, I work in digital services. So everything I will describe here is enabled by APIs and Terraform, as we're doing in the background. The second key component here is network edge. So Fabric provides the underlying connectivity, but we still need BGP speaking endpoints to actually connect these clouds together. And for this deployment, that's where our network edge platform, which is really network function virtualization as part of our Fabric, comes into play. So we've built dedicated infrastructure inside of our environment, which is really there to host a marketplace of leading SD-WAN routing firewall vendors to deploy their images as a service. And that's what we're going to be using as part of this deployment to bring those cloud environments together. There's also a third or a newer one that I'm going to mention. It's not what we're deploying today, but more of a sneak peek. And this is to do with a lighter weight connectivity model, whereas I guess Network Edge is really focused on vendor solutions and it is, the full fat image. We are rolling out a lighter weight cloud router, which is a little bit simpler to deploy, obviously not as feature rich, but for, I guess, more simple connectivity use cases, will provide a very similar outcome in this whole multi-cloud topology. So again, not what we're deploying today, but if you are interested in a lighter weight version of what it is that we're doing, that will be an option in the future. And so with those components, I just wanted to talk about, I guess, a visual on how we enable this multi-cloud. And our focus today is really on the hyperscale clouds out to the left, predominantly Oracle in this demonstration, with Equinix kind of being that glue in the middle. So the fabric network plus our network function virtualization, or Network Edge in this case. And today we will be demoing the Cisco Catalyst 8000 as part of our deployment. But multi-cloud isn't just hyperscale cloud for a lot of our customers as well. There's SaaS out there, there's private cloud, which might be deployed inside of our facilities, as well as things that sit outside of these ecosystems, potentially on-prem. And that's where sort of network service providers and last mile connectivity come into the picture as well. And so in the multi-cloud world, I guess Equinix really sits in the middle as providing that glue between all of these disparate cloud solutions to actually be the true foundation of multi-cloud in this context. And so hopefully that set a little bit of the scene around, I guess, Equinix's role in this whole thing and why we're co-presenting with Oracle here today. And with that, I'm going to pass over to Ejaz to give us a bit more background just on the multi-cloud landscape.
Brilliant. Thanks, David. That was great. So, hi guys. Oracle's strategy is really with the distributed cloud. Our vision is to meet with customers there they want to meet with us. And as you can see, we have got different offerings to actually underpin that strategy. We have got multi-cloud native products. Either it's just any cloud service which you can use with any other cloud service to make the best solutions you're looking for. Then we've got our public cloud offerings. Either they are the commercial regions or the gov regions. You have got tons of services to use, as well as we are offering now European sovereign cloud as well. So to keep for the customers who want to have more, local data residency requirements. Then we have got offering in hybrid cloud, where we can bring the cloud to you into your data centers. Exadata Cloud at Service has been out for some time, and most recently we have announced Compute Cloud at Customer, and that's a great addition for customers to choose to underpin all the solutions they are looking for. And finally, we have got a dedicated cloud offering as well, where customer has got either very low proximity or compliance reason to run all the services under their own control with no neighbors, basically. So we can provide that, and we have been giving this option to a lot of customers to use that option as well. Next slide, please. Okay. So what I wanted to also share that what we are seeing in market for the typical kind of multi-cloud use cases. And again, with our services and with the partner services, we can enable customers to achieve that. A split stack application is quite common use case where customers have got developed their, the app stack in a particular CSP. Whereas the maybe the database services, the data management services, they're running with us in OCI. Workload mobility is another one where the workload is pretty much distributed within different clouds, either it's for cost performance or any other security compliance reasons, as well as app-to-app integration, where again, your application, a full stack application might be running in one of the cloud providers, but you're actually interpreting with the other cloud provider, and we're going to see how we make that happen. The fundamentals or the basic building block through this demo we're doing today with Equinix. Likewise, we have got SaaS to platform integration as a very common multi-cloud use case as well. So different SaaS applications running in different cloud providers, where they want to, integrate with the other cloud provider for business agility and innovation. Then we have got a data analytics pipeline. And I think that is another one really great use case for multi-cloud, because you could be having a lot of data warehouses in different cloud providers, which are either your primary or even secondary, but you are doing even data lakes and stuff. But the key thing is how quickly you can actually analyze them and get timely business reports from them. So those are very typical multi-cloud use cases we have seen, and I'm sure you guys are working on these. And then finally, I want to share from my end is the different connectivity offerings we provide within Oracle Cloud Infrastructure. So we've got Fast Connect partners, which is where Equinix is obviously one of our key partners, where we can integrate with their Fabric, and other partners have got the similar offering. Likewise, we also provide the simple VPN. So if you're just running some test and dev, you might want to just hook up with VPN, and we can just connect them quite easily with all other providers. With Azure, we have got some more closer partnerships. So we have Azure Interconnect, which has been out since 2019, and most recently, we have got Oracle Database Service for Azure, again, giving customers to build all the multi-cloud solutions as they need. I think that's from me. Ricardo, over to you.
Yeah, thank you, Ejaz. Okay, so now that we kind of understand which are the different multi-cloud connectivity offerings that we provide in Oracle together with our partners, now we need to understand which are the options that we have for actually doing the deployment. So yeah, so probably the first one is also what David mentioned, is just by using the graphic user interface or the portal of the specific vendor. So this process is what's recently being called as ClickOps, as the ClickOps way. And basically it's called like this because there are some points that are not so positive about doing this. The first one is that it's a really manual process. You need to go through the different menus or different specific portals for just deploying something. Of course, at the end, this is time consuming and it's more error prone. And it's also more difficult when you want to scale. If you want to redeploy something several times, then you have to do it just repeatedly. So this is just when we talk about in one cloud or in one single deployment. But when we talk in a multi-cloud ecosystem, the challenges are even greater. Why? Because every provider has a different look and feel they have. They also constantly do updates to their user experience and user interface. They do upgrades. And at the end, this translates in a lack of a single method for managing your multi-cloud infrastructure. Then, of course, in the other side is the main goal of this session, which is try to go into an infrastructure as code model. And I also saw on the initial poll that still not many people is fully adopting infrastructure as code. And I would say that particularly in networking, this is a forgotten point. So this is changing now. Providers are trying to foster a bit more automation in networking. And of course, in public cloud, there are some benefits for doing this. But let's say that in general, infrastructure is not where automation was typically done, and in particular networking. And of course, me having a networking background, I think I can highlight that. Then here on the bottom of the slide, I highlight a blog that was actually written by Equinix, where it's clearly explained this ClickOps versus infrastructure as code model. Okay, so if you want to read further, there you have the link. Okay, so now that we know this infrastructure as code and API integration model, we want to understand which is the current offering by the two partners that we're here, Oracle and Equinix. So in Oracle, one of the things that we want to do is we want to simplify the deployment of the landing zone with infrastructure as code. And we want this landing zone to be fully compliant with all the security or the main security constructs. So for this, actually in EMEA, we have a domain specialist team that is creating a public repository where you will find all your information for doing this, for deploying your OCI landing zone that is going to be CIS compliant. And actually, this is something that we used during this session on this demo, and I'm going to guide you and show you exactly how I did this. So this, let's say this is something that you can use for your initial deployment, but it shouldn't end at this point. Once you go into this journey of automation on using Terraform, you should this should be the way forward. You should not go back to the ClickOps way. So for this, in Oracle, we also have a set of day 2 operations that simplify and facilitate this. So, well, some of them are DevOps, code repository, resource managers, Terraform stacks, and much more. And well, and from Equinix side, they have an API integration system, and within this API integration system, pretty much you can deploy everything you need for a multi-cloud infrastructure. Well, of course, also for the hybrid infrastructure, but here you can deploy whatever what you need for your multi-cloud infrastructure. So now, going back again to the interesting thing, what we're building in this session. In this session, what we will be building is first a multi-cloud connectivity between an OCI region and the AWS cloud. In particular, we're doing this deployment in Frankfurt, in the Frankfurt region of OCI, and this is what David did the initial Terraform apply at the beginning of the session. So from the OCI side, the connection is going to be connected at the DRG. DRG is our gateway for managing networking. And then on the AWS side is going to be terminated on the Data Connect gateway. And in the middle, there is the Equinix as the glue for permitting this connection. So for this, well, as we have explained, we need two main products from Equinix. The first one is the Fabric, the Equinix Fabric, which provides this layer 2 connectivity. And then we need the Network Edge, which is the network virtualization. For this specific demo, we'll be building here a Cisco 8000B. And the Cisco 8000B, this router, virtualized router, is the one that is going to be responsible for setting up the BGP sessions between the clouds and Equinix. Okay, so at the end of this session, we will also be sharing all the resources for actually building this, so the code for actually building this. So this is why we put here that this fits into a brownfield deployment, because let's say you can have an OCI landing zone and AWS landing zone. Now you want to connect them, and you can just use this. But yeah, so this is why we say it's a brownfield. But of course, if you actually want to do it from scratch, you could also do it. Okay, so now I'm going to quickly explain and guide you about where we actually have the code and what we do from OCI side to simplify this. So let me jump quickly into this. So as I explained, in Oracle, we're working in this OCI CIS landing zone for networking. And within this repository, we have different branches. And as you can see, we have a specific branch for multi-cloud. So if we go here into multi-cloud, in the examples part, is where we have this specific scenario for a fast connect partner, which in this case is Equinix. So here you will find the code, and not only the code, but also all the information for getting this working. So let me quickly explain you what we've done here, or what you will be able to do. So the first thing is that you can clone this repository and use it. And for this, the first thing that you will have to do is just to provide the information of your specific tenant. So for this, there is a Terraform TFVars template or a Terraform TFVars file within the main folder. So here is where you will have to provide your specific tenancy information. After you do this, you will be pretty much ready to deploy the OCI networking Terraform file. And I think that I want to highlight about this Terraform file is that we're providing the configuration in a JSON format. So what we're doing is we're abstracting all the Terraform resources and putting them in a simplified JSON file. So what we want to achieve with this is to simplify the deployment of an architecture, and also making this architecture that you can configure it as you need. So for example, in this scenario, we only have one VCN, which we call Vision VCN Key VCN. But let's say if you want to create another VCN, it will be a matter of just copying that VCN and pasting it within the VCN structure. And you do the Terraform apply and you get another VCN. So it's just quite simple. So pretty much if you just copy and paste and update those records, you'll get this working. So this is from OCI and what we are providing in this CIS landing zone information. We're providing a JSON structure so that you can prepare your infrastructure. Then let's try to understand a bit more about the flow for this multi-cloud connection. In OCI, the fast connect is responsible for providing the private connectivity. And well, the fast connect is the responsible for providing that private connectivity. So the first thing that we need to do for this multi-cloud connection is to actually deploy the fast connect. Once we deploy the fast connect, we will get an OCID, which is basically an ID that identifies this connection. And this is the ID that we will use in the Equinix deployment. So the process is first we deploy the fast connect, we get the OCID, and then with this OCID is the one that we use in Equinix for building the rest of this design. In this particular scenario, we wanted to keep isolated, let's say, the owner of the OCI account and the owner of the Equinix account. So this is what we did here, was just to get the OCID and then just share it with Equinix via email or just send this ID. As you will see, we're only sharing the OCID. There is no more information about our tenant. We're not sharing the tenant, we're not sharing a compartment, user, password, anything, just the OCID. But in the other hand, if a customer wants to deploy this for testing this scenario and they're owners of the OCI account and the Equinix account, they can just simply put all the Equinix information here and just use the OCID from the virtual circuit. And from a Terraform apply, they will be able to get this full connectivity, multi-cloud connectivity working. So I think this is really, really cool. So again, here you'll have this example from multi-cloud connectivity partner. Here you have different Terraform files for getting for connecting to your tenant. You'll have to update the Terraform TF-parse template and then just adapt the OCI network configuration accordingly, just by editing this simply JSON file. Okay, so I'm going to go back to the slides, and I think that also back to David. Okay.
Thank you, Ricardo. So just quickly, right, I'm going to jump into the repository that's enabling this from our side. And so most of this is done via Terraform. It's all infrastructure as code. And from our side, really leveraging, I guess, Fabric and Network Edge as the main networking components for this deployment. But not every cloud interacts with our platform in the exact same way. So you would have heard from Ricardo that the only handoff we get from Oracle Cloud in this case is the OCID of the Fast Connect. But for other providers, like for the topology we're doing here with AWS, those interfaces might look a little bit different. And so if we're connecting AWS in this case, we need a slightly different handoff, which is the account ID. And so your mileage will vary with the type of information you need to put into, I guess, this multi-cloud scenario, depending on how the hyperscale cloud has connected with the environment. The other important thing to note, and it's a very similar diagram to Ricardo's, is we can do all of the underlying infrastructure as code, but some of this other configuration, like setting up the interfaces, configuring BGP, things like that, we're actually going to use a different interface. And in this case, we're going to be running Ansible to interact with the Network Edge device and actually push some config, which is really responsible for the interface configuration, as well as setting up BGP to both cloud environments and where necessary, in the case of AWS, things like BGP passwords. And we really wanted to separate out those two functions because Ansible is very good at the configuration management, and I guess Terraform is a lot better at the infrastructure side for these deployments. But just quickly, I'm going to jump into the Edge console here. So this is Equinix Fabric and Network Edge console, so where we deploy our infrastructure. And the first thing you'll note is when we come into this particular deployment, we're going to find the network edge device that we kicked off during the automation. So our Catalyst router sitting in Frankfurt. Standard information about the device. There'll be some information in here around the connectivity we're building as well. So as I mentioned, the network edge is really responsible for the network control and BGP inside this environment. And Fabric, which are these virtual connections that you're seeing down here, is really responsible for stitching together this virtual device to the actual cloud endpoints themselves. And so between those two, we can essentially create the topology that we've seen here, and then overlay, I guess, Ansible to do all of the higher level configuration beyond layer 2. So coming back to the code here, I do see my AWS private interface is still deploying right now, and we'll jump back to that in a minute for the end-to-end test. But really, the main interfaces that you'll find, I just realized we're recording this, right? Maybe we can scrub out those credentials. The main interface you will find between the two, I guess, deployment methodologies is using Terraform to invoke our Ansible playbook. So obviously Terraform does all the infrastructure, but to make this whole end-to-end deployment happen in real time, I guess, we then need a handoff between Terraform and Ansible. In a real deployment, I would say that this isn't the right way to do it. We should probably break up those into two distinct processes as part of this whole automation. But just for the sake of end-to-end automation, we've done it this way. And if you wanted to run this in your own environment to test, I would advocate that you break these out as well. The last thing I wanted to show you in here whilst we just get our private interface configured is how we're actually constructing the cloud endpoints. So today we're really focused on Oracle connecting to other things, and specifically right now, a split stack between Oracle and AWS. But of course, there are other clouds that you probably run parts of your infrastructure in as well. And so inside of our vars for Terraform, you can actually extend this environment using a very similar methodology to what you see here. So if you had infrastructure running in a different cloud provider, all you'd have to do is replicate one of these blocks, pass some basic information around the environment itself. So maybe you're connecting off to GCP. You would simply provide some interconnection networks, the remote AS numbers, things like that, passwords where necessary. And then you're going to essentially end up with something that can replicate across any other cloud that you need to connect to. And so that's the premise of this framework that we've built with Oracle, is to make your Oracle cloud extensible into any other environment that you might need to connect to. Now with that, I'm not going to jump into the AWS console, but we've got a couple of minutes here. I'm guessing 1 minute before this virtual interface comes up. I'm not sure why it's taken quite this amount of time, but that's the joys of live deployments, right? You never quite know how they're going to go. We'll be there pretty soon with this one. So I'm not sure if there's any questions from the team or from anyone watching as we just wrap up this final step in the Terraform. If not,
David, I'll interrupt you and just give you a second when that finishes. What's if there was one or two problems that always crop up? What's the most likely issues that people have? So there's probably one you get asked a million times. Well, what's the first top 2 or 3 that you have?
So my biggest issue, and normally I run a lot of this in test style environments, so it's with high velocity, is when you keep building and tearing things down. I think the front end of a lot of these systems works really well, but the back end might get a little bit stuck. And Ricardo and Ejaz can probably attest to this. Like when you're trying to do all of this, like tear up, tear down, tear up, tear down, the chances are like it'll work really well a couple of times, but repeatedly, some systems in the back end for these various platforms aren't always up to the challenge of interacting that fast. So it's a really good way to build in environments generally. But like we're probably seeing here, there's, I'm going to assume, an error that came out of here where a resource from an earlier deployment kind of lingered in some capacity, and it's not quite up to state, I would say. The other challenging part, and I'll show you this hopefully in a minute, is the dependencies in Terraform. So it doesn't always behave the way you would expect it to with, say, life cycling of resources. So the way you write the code and I guess apply and then reapply can actually have a different impact to what you would expect. So making small changes sometimes means other resources get heavily impacted. Like some of the testing I was doing earlier. In here, you will find just to make it easy to identify, as an example, I'm using some of these random strings, and often a reapply will build a new random string, and then that random string will propagate through. And because you're changing that variable, it'll ultimately destroy a lot of things that I never intended it to destroy. So really understanding how each resource gets life cycled, especially if you are doing dynamic stuff like we're trying to do here, is super important. Perfect question though, Tom, because we now have some outputs. So what we've got, and the only output I'm going to show here is the interface IP of our network edge device. So the first thing I'm going to do is log into this device, and here's most of the one I prepared earlier. And this is the multi-cloud router that I showed you in the Fabric portal. So if we do, and this should be fine, yeah. So if we show what's running on BGP, essentially our Ansible scripts have gone and built BGP router 65,000 and popped 2 peers into here. So we've got a peer for OCI on their remote AS and a peer for AWS on a private AS. If we then go, show IP, I guess, you'll find that similarly, we've gone and configured our interface IPs to match what's populated in the variables file for Terraform. So that's really the main 2 functions of Ansible in this, is to configure these IPs, open them up, and then build this BGP router. From there, I can log into, I guess, my EC2 instance. And the goal here is to kind of show the end-to-end testing. So this IP is for my EC2. And what we should be able to ping from here is across the fully private path that we've built. So across Direct Connect, through the network edge, and back out the Fast Connect into the VM that runs in OCI, which is actually this IP address here, and Ricardo might be able to confirm this, but what you'll see is end-to-end, we have connectivity up, very stable connectivity, and obviously very low latency. So,
as I mentioned, we did this whole deployment in the Frankfurt region, so everything is in the Frankfurt region, but yeah, I just as David explained, the latency is quite good and stable, I would say.
And really, that's the goal of this whole webinar, right? Is to show how we can move away from ClickOps to a model of operating, which is infrastructure as code, and ultimately automate a lot of the underlying infrastructure needed to support multi-cloud architectures. I can probably stop this ping. So I'm not sure, Ricardo, if I'm throwing back to you.
Yeah. Okay. So thanks a lot for this, David. One of the key questions that we also get, or the comments, is that why do all this with Terraform if at the end it's a one-shot, at least on the networking or on the multi-cloud connection? Why do it like following this approach if I can just do it directly on the GUI or on the portal? I would say that there are many benefits about doing this in an automated manner. But the first one I would say is just to change your mind about how you do this. We're now working with several customers that just want to do everything automated. They just want to have everything integrated in their CICD, and just treat infrastructure always as code. So it is important to know that you're able to do this also for your multi-cloud connections. And again, we also believe that multi-cloud is not something that is going to be so static as probably was in the past, a connection from your on-prem data center to the public cloud. now this is continually evolved. So now you may need one connection to one public cloud, then and need another one, then reshape the bandwidth more. So we believe that with this approach, is simpler to do this. So now some of the useful resources that we have been using in this session. So 1 second, okay. Yeah, so for this, the first one is the code repository. So we have the two main code repositories, the one for the OCI CIS landing zone, where you have everything for building up your landing zone CIS compliant. And specifically, there is a part for multi-cloud. Now, in that part for multi-cloud, you will find this specific sample for a partner with Equinix, but this is something that will continually be expanding. So we'll be adding more content and more code into this so that you can use it. And then from Equinix, this is going to be hosted in the Equinix lab, where you will find all the code that David used during this deployment. Finally, there are just portals, key portals. That was the first one. Also in the poll, some of you mentioned that you've heard something about multi-cloud in OCI, but in OCI we have, as we're talking now, the partner connectivity, but we also have a strong partnership with Microsoft, and for that we have different products. So if you want to understand a bit more, this is the portal. And well, finally, for Equinix Fabric, Equinix Network Edge, detailed information. And the last one is this blog about written by Equinix about the importance of going to an API integration and infrastructure as code model. Okay, so I think this is all from us. I think, Tom, you can take control now.
I think we've got a question. Probably we can ask David. Amit has asked if we can run traceroute between the destination and source.
You want to see it from our deployment right now?
Yeah, I think that's what.
Yeah, take back over, David, if you want to show something.
Let me double check. Yeah, I've got traceroute on this Ubuntu. So, still running. But essentially, the traceroute will be across the 192.4 interconnect, which is going to be my AWS. The 4.1 interface is going to be network edge. And then this is going to be into the OCI interconnect. So there's a bunch of things, I guess, on the OCI side that aren't responding to the traceroute. But it's essentially across the private networks that, if I go back into here, are going to be defined as the dot 4 is going to be AWS, and then the dot 3 is going to be Oracle. So it does move across all of the private interconnects that we just built, as opposed to out the internet.
Perfect. Thanks, David. Well, I don't have any other questions in the chat I can see, so we can get back to Tom.
Cool. Thanks. Other than that, we can close the call kind of 10 minutes early, unless there's any burning last questions that people have. I'll just end that poll, and thank you again for that information. It's greatly appreciated. If there's no burning last questions, okay, maybe there is. Recording, yeah, Nicholas, the recording will be shared. You'll get an email, and we post it everywhere. Right, I'm an equal opportunity spammer when it comes to this, so it'll be on all the Slack channels we have. You'll get it an email. We're on Oracle. We'll be on the Oracle Developer YouTube channel from now on. We've some other stuff on the Oracle Learning channel, but we're migrating to our real home, which is should be Developer. So you'll see it over there. With that, thank you all for attending. Hopefully, I'll see you next week. And hopefully, if you found it helpful, remember, if you join on Slack, got any questions, you can follow up over there. And with that, I'll bid you all farewell. Have a great day and look after yourselves.